Hello, everyone. This is the lecture for section 1.6, the absolute value functions. So in this section, we're going to just solely cover what the heck an absolute value function is. So first thing we're going to do is just define it, and then going to play around with how to solve certain versions of these absolute value equations. They tend to show up a lot later on in the course, okay? So the first thing I need to do is define the absolute value function itself. And it's usually these two double bars that are on the outsides of whatever expression that you want to do, okay? And it is defined as the distance from zero, okay? What people tend to remember about the absolute value function is this, right? Is that whatever's inside, right? Whatever's inside the two bars, whatever that is, it's just positive, okay? Not exactly what the absolute value function does. It actually just gives the distance away from zero. So for example, right? Let me go ahead and draw a number line here, okay? And let's say this is zero, right? I'm going to take two values, right? -5 and +5. Okay, so keep in mind, right, that what the absolute value does is it gives the distance away from zero, right? So if you take a look at this distance right here, right, that distance is 5 away from zero. So that's why what we say here is the absolute value of 5 is equal to 5, okay? Same idea this way, right? This distance away from zero is 5 spaces away from zero, right? So this is why we say the absolute value of -5 is equal to 5, okay? It does turn everything positive, right? But not for the reasons that you think. It's not defined that way. The actual definition of it, right, is the distance away from zero. That's why the absolute value of -5 is +5, okay? Because it's still 5 away from zero. Okay, let's do a little bit of review from the stuff that we were doing in our previous section, okay? Use your toolkit functions, right? Especially for these, right? So let's take this function right here. We sort of know what the absolute value function looks like, right? And we want to graph this thing right here, okay? All right, so hopefully you guys remember this at least, right? This and this were very particular. So the -3 meant we're going to move it toward the positives in the horizontal direction, right? And then the +4, I'm going to move it vertically up and down, and that's according to the sign itself. Okay, so that means this point ends up moving 3 toward the positives and 4 in the positive direction upward, right? So 1, 2, 3, 1, 2, 3, 4, right there. Okay. Now, there is this, a 2 up front, right? And if you recall, that's your vertical stretch. We're going to grab it. We're going to grab the original graph. We're going to grab this original graph and sort of grab it from the top and the bottom and stretch it out, right? Now, how do we do that? So hopefully you guys see this, that your graph is sort of going over 1, up 1, over 1, up 1, over 1, up 1, right? What this thing changes is the over 1, up 1, right? Instead of going over 1, up 1, it'll go over 1, up 2, okay? So my new point from here, right, is going to go over 1, up 2. I don't have much space to graph here, but it's sort of a, there we go. Something like that, right? So if you guys see, the graph does this now. Bam. Okay? All right, let's move on. So now here's where I'm going to show you guys how to solve, at least without anything special right now, right? We're going to do finding x and y intercepts down below, and this is going to require us to know how to solve stuff, right? So let's say I need this graph right here. I need the equation for this graph. Hopefully you guys have something of an idea of what's going to happen, right? I need to put it in this form because this is the form that we know, right? So automatically, right, because of this point right here, because of that point right there, we can automatically say this is going to be an f of x, right, equal plus or minus, let's leave the plus or minus there for now, right, a x minus, the h was supposed to be the horizontal shift, the side to side, right? We can see that this graph got moved over by 3 in the positive direction, right? So that's going to be a minus 3. And then the plus k, we can see that it got shifted down by 2. So this has got to have to be a minus 2, right? So now what's missing is this part up front, the plus or minus the a, right? So automatically, right, you guys know that the absolute value function is that, right? It's that v thing, okay? And since it's facing upward, we know that it's positive. So that automatically takes care of the plus or minus. We know which one it is. It's going to be plus, right? So f of x is equal to plus a minus 3 minus 2. Okay, we're good. We're doing okay. We now need to find that a. We now need to find that a, okay? So here's the part where we're going to solve out the rest of the equation. We're going to solve out that a, but we're going to use one of the points that is present on the graph itself. So I'm going to use this one. I'm going to use that point right there, right? And that point right there, I'm going to write it down here, is, that point right there is 4, 0. Okay? So I'm going to use that point, 4, 0, to solve out my a. So that means, according to what I have written, right, f of 4 has to equal plus a x minus, whoops, not x anymore. It's going to be 4 minus 3, right? 4 minus 3 minus 2. And the output of all of this should be equal to 0, right? Because f of 4 had to be equal to 0. That's what that point told us, right? Okay. Now, we get to solve this out, okay? So 4 minus 3 is going to be 1. Absolute value of 1. Minus 2 equals 0. The absolute value of 1 is 1. 1 times a is a. So a minus 2 is equal to 0. So we get to solve this portion right here. A is equal to 2. So our function, our f of x, and this is our final, right, is going to be equal to 2 x minus 3, absolute value, and minus 2. And we're done. Okay, now, some of you guys might be thinking, why all that work for this number right here? And you're right. If you take a look, I explained it in the previous example, right? We went over 1, up 2, over 1, up 2, over 1, up 2, right? That is equivalent. That gives us the 2 that we needed up front to begin with, okay? All right, so let's move on to finding x and y intercepts, okay? This is really, really going to be something that we're going to do because we're going to be messing with graphs all throughout the semester, okay? This is really something that we're going to need to get down pat real quick, okay? So let me define what each one is first, right? And then we'll cover how to find each one, okay? So an x-intercept, right, is where a graph crosses or touches the x-axis, okay? And the same thing for the y-intercept. A y-intercept is wherever it crosses or touches, crosses, in this case, the y-axis, okay? All right, so now we need an overall process to figure out how to find x and y intercepts, okay? And the overall process, this is how I like to remember it, right? Let me write them down first. There we go, okay? So for the x-intercepts, we set the y equal to 0 and solve for x. And for the y-intercept, we set x equals 0. So they go backwards, okay? And that's usually how people remember, okay? So if you want x, you set y to 0. If you want the y-intercept, set x equals 0, okay? Now, what we're going to do now is we're going to try to find x and y intercepts of our absolute value functions, right? And that's going to require us to solve an absolute value equation, okay? There's 3 steps, okay? The first step for solving an absolute value equation is to isolate the absolute value bars. Okay, and I'll demonstrate this when we get there, okay? Second step, right? What's going to end up happening is you're going to get 2 equations, right? One side you're going to set positive, and the other side you're going to set negative, okay? And then after that, you're going to solve both equations separately, okay? And that's how you do, this is how you solve absolute value equations, okay? All right, so I do want to cover an example of what we're going to be doing, okay? So suppose I had this function right here, and no matter what, right, you can verify your work using Desmos, right? This is how you do it algebraically if you didn't have a graphing calculator on you, okay? So suppose I wanted to find the x and y intercepts of this thing right here, right? Just by pen and paper, okay? So what we're going to do, let's go ahead and do the y-intercept first, okay? So the y-intercept told me to set x equal to 0, right? And solve for y. So that means I set my x equal to 0, so f of 0, 4 times 0 plus 1 minus 7. This is going to be 0 plus 1 minus 7. And this is minus 6. Okay, so our y-intercept, 0, comma, minus 6. It's minus 6. Minus 6. There we go. Okay, that is our y-intercept. Okay, so if we graph this thing, we should expect our graph to cross the y-axis at -6. Okay. All right. So let's do the x-intercepts now, right? Okay, x-intercepts. Okay, this one is the one where we said we need to solve, we need to set y equal to 0, okay, and solve for my x's. This is the one that's going to involve our 3 steps from above, okay? So what I'm going to do, right, f of x is equal to 4x plus 1 minus 7 is equal to 0. This is the thing that we're going to solve, this right here. That, okay? And that's going to require us to do the stuff in step 1, 2, 3 that's above it, okay? So the first step is to isolate the absolute value bar. So you guys see these 2 bars right here? Yep, I need to get that by itself. So, and to do that, right, my minus 7 is right here. I get to throw that to the other side. So 4x plus 1 is equal to 7. I've isolated the absolute values, okay? Now we're into step 2, okay? Step 2 says I get 2 equations. One of them is the positive and one of them is the negative, okay? And I like to do it this way, and I'm going to go ahead and move up here. So I'm going to do 4x plus 1. I'm just moving it up here so that you guys can see that this is going to be the 2-step thing, okay? I'm going to grab this, and I'm going to make 2 equations out of it. One of them is going to be the positive version of the left-hand side. So 4x plus 1 is equal to 7, and the other one's going to be the negative version. So minus 4x plus 1 is equal to 7. Okay. Some people remember it 7. The other way that people remember to do these is to stick the negative in front of the right-hand side. No difference there. I'm keeping up with the notation. The thing that should be getting positives and negatives is whatever is inside the absolute value. That should be the thing that's getting the positive or negatives, okay? If you ever study math for the rest of your life, then it becomes important. For now, no biggie. You can give the negative to the 7 instead, okay? All right, but now we get to solve both of these separately, okay? So then here, this is what you remember from high school. So -1, -1, 4x is equal to 7 minus 1, that is 6, divided by 4, divided by 4. X is equal to 6 over 4, or what is that, 3 over 2. Either answer is fine with me. Okay, that's half of it. The other half, over here, minus 4x minus 1 is equal to 7. I need to distribute that negative inside. Plus 1, plus 1. Minus 4x is equal to 8. So that means x is equal to -2. All right, so my two x-intercepts will be 3 over 2, 0, and -2, comma 0. So if we graphed this right here, if we graphed our function f of x, right, then we should expect our graphs to have an x-intercept at 0, comma -6, and we should have x-intercepts at 3 over 2, comma 0, and -2, comma 0. So it should cross at that x, this x, sorry, it should cross at this y-intercept, and it should cross at these two x-intercepts right here. Okay, all right. This is a quick check for us to do in class. Okay, if you want to try it on your own, go ahead. And we'll get these during class, all right? Okay, so now is a very particular question that I need to cover, and this will be something that pops up on a regular basis if you do any of the harder sciences, okay? Will there always be two answers when solving an absolute value equation, or will there be two x-intercepts when graphing an absolute value, right? Okay, and the question to both of these is, give yourself a second. Okay, the answer to these is no, not always. Okay, I'm going to give you an example. Okay, I'm going to take this function right here. F of x is equal to absolute value of x plus 2. Okay, so hopefully you guys already see what this graph is going to look like. Okay, 1, 2. Here's my graph. I'm not gonna draw it exactly, but close enough. There we go. Okay. So now the question here is, does it cross the x-axis? Do we have two x-intercepts? And the answer is no, we don't have any. So this has no x-intercepts. There's no x-intercepts for this. Okay. So this function, right? If we solved out for the x-intercepts, we won't get any solutions. Okay. This version, the way that I have it graphed right here, right? This shows us that we have an absolute value function, but it does not have any x-intercepts, right? It does not have any x-intercepts. So now, here's the thing that I want to do, okay? Let's, for kicks and giggles, right? X-intercepts. Let's find them, okay? So the rules from above say that if I want to find an x-intercept, we need to set y equal to 0, right? So I need to do f of x is equal to absolute value of x plus 2, and we need this to be equal to 0. All right, we're off to the races. Okay, so we have to solve this out. So not yet. Minus 2, minus 2. Absolute value of x is equal to minus 2. Okay, now here's the important thing. That right there. That cannot happen. Okay, so if you remember, right, from the very beginning of the class, the absolute value, right, is defined to be the distance away from 0. Okay, so what we're trying to say here with this yellow thing that I have highlighted here, we're trying to say that we need the distance away from this value x to be -2. We need to have a negative distance. This cannot happen. Okay, and the reason why is from what I just said, right? So no negative distance. Okay. The other way that you can remember this, right, is what does the absolute value do to any number that's inside? So what in between the bars, right? It grabs everything in between the bars and just turns it positive. Okay. You're asking, so the thing that's highlighted in yellow, right? You're asking something that's got to be positive to be equal to something negative. Can't happen. That's the other way you can remember it, right? So then this produces no x-intercepts. We're done, right? Okay. This is actually a pretty good way to get yourself out of doing extra work, right? And let me show you what I mean by that. Okay, let's say I wanted to solve this out. Okay, so I'm going to rotate it. I'm going to do this for x minus 2 plus 2 is equal to 1. It's the same thing. It's just the other way around. Okay, I'm going to try to solve this out. Okay, so I'm going to go ahead minus 2, 4 x minus 2 is equal to -1. I'm going to still keep going. I need to isolate the absolute value, right? So I get to divide by 4, divide by 4. Okay, we're going to go up here. X minus 2 is equal to -1/4. We have the same scenario that we have up above. We have the absolute value equal to something negative, right? That cannot happen. So this is no solutions. We are done. Okay. Whenever you see something that looks like this, whenever you see something that ends this way, absolute value equals something negative, you can automatically just put down your pen or pencil and just keep moving. This has no solution at all. Okay. All right, this is as much as I wanted to cover for the absolute value. This is going to be a short video. Okay. After this is the lecture questions. If you guys have any questions, please ask me during class or during my office hours. Besides that, happy studying.